Measuring the spectral responsivity of photovoltaic devices in this manner, one is faced with the problem of having to discriminate between the photocurrent generated from the monochromatic probe, which we seek to evaluate the spectral responsivity, and the photocurrent generated by the light bias, which we can largely ignore. In the PVE300, we circumvent this problem by optically chopping the monochromatic probe. In this way, the photocurrent generated by the device can be passed through a transformer, the 474 transformer. The transformer will pass the photocurrent generated by the AC monochromatic probe, but block the light generated by the DC light bias. The signal is then passed to a preamplifier before going to a 496 lock-in amplifier for signal recovery. To that end, an optical chopper is located within the dual source, which will optically chop the light beam input to the monochromator. The chopping frequency is selected based on two main criteria. One, that the chopping blade used must be such that the level of illumination at the cell at no time becomes a constant, i.e. it is continuously varying. And we must also function at a frequency at which the transformer functions optimally. And for that reason, the frequency of 580 Hz is taken as standard. 580 being away from the 600 harmonic of the mains frequency. In the majority of photovoltaic device cases, one can measure successfully the spectral responsivity EQE in this manner. However, the 580 Hz chopping frequency is not compatible with devices with slow electron transport mechanisms, such as the DSSC. In the case of DSSCs, for example, the optical chopper is stopped, such that the monochromatic probe is no longer optically chopped. The photocurrent generated by the device is then passed directly to the 497 preamplifier, and on board this device there exists an ADC converter to pass the result to a computer. In this case, it is not possible to use a light bias. The light bias would otherwise be very much larger than the photocurrent generated by the monochromatic probe to render the measurement very difficult, if not impossible. Where one wishes to measure DSSC cells with a light bias, albeit a low-level light bias, there is the option of the DC chopper. In this case, the light input to the monochromator may be blocked or not as required. The cell response is measured in the presence of the light bias in one case, and in the other case in the presence of both the light bias and the monochromatic probe. And in this way, a measurement of DSSC cells may be performed at low levels of light bias. The 497 preamplifier also serves as the preamplifier to the lock-in amplifier. In this case, one can modify the chopping frequency from 60 Hz up, so one is no longer limited to the 580 Hz of the 474 transformer, and one can benefit of a higher level of gain of this amplifier with respect to the 474 transformer preamplifier. And this means it can be quite useful to measure experimental devices and research-grade devices with lower responsivities. Indeed, in measuring the reflectance and transmittance of devices, we use the 497 as a preamp to the 496 lock-in amplifier to give us a high level of sensitivity when measuring the very low levels of 0% reflectance, for example. The 218 optical chopper controller is set to a frequency on the dial around 280 Hz. This dial is true for 10-slot discs, whilst in the dual source a 20-slot disc is provided. The actual frequency is twice that, and in fact one can see on the front panel of the 496 lock-in amplifier the frequency reported. The 218 in the on position allows for optically chopping the signal. In the 497 DC mode, one can simply power off the 218 in which case the arrestable function of the 218 using an electromagnet will be implemented, and the optical chopping blade will be stopped at an open location, allowing light to pass into the monochromator. In the case of the 497 AC mode, one has scope, should one require, to change the chopping frequency applied. Whereas in use of the 474 transformer, one should always maintain 580 Hz chopping frequency, and certainly not a harmonic of mains. In the 497 AC mode, not using the transformer, one has scope to reduce the chopping frequency if required. The chopping frequency can simply be changed by turning to the right, the locking fixed piece, and reducing as required the frequency on the optical chopper. We recommend with a 20 slot blade a frequency no less than 60 Hz be applied, that is 30 Hz on the dial of the 218.